Can I see?
Sir, can you unmute your mic, sir, please?
No? Can you hear me?
Yeah, clear, sir. You proceed, sir, please.
Yeah, good afternoon. At the outset, I would like to congratulate Dr. MGR Educational Research Institute for taking the proactive initiative building their own satellite, Dr. MGR ACS satellite. I thank the management, particularly chairman and president, vice chancellor, and other officers of university. It is the initiative by our rector, R&D, Dr. Vishwanathan and his team with Cyril Raj and other registrars. As a part of this initiative, today we are having this national seminar. I would like to share few of the success stories which led to this 75 satellite consortium. In spite of COVID pandemic, we could able to build and launch 3 small satellite, nano satellite or pico satellite we can call, successfully with PSLV. Can you hear me? Because I got a call from your university.
Yes, sir. Yes, sir. We can hear you. Please go ahead, sir.
So these 3 pico satellite built and launched in spite of pandemic entirely in India. Screenshot. Video. Yeah, there was some small technical glitch there. So look at the pictures with the ISRO chairman after the launch. It is at Sriharikota. I think Mr. Bogle is there. He knows very well. It was a big celebration. After that, all the 3 satellites have performed very well in the orbit. Then we had a success meet. Bottom picture shows with our former Deputy CM and Minister for Science and Technology, Dr. Ashwath Narayana at Leela Palace Hotel. So after the celebration, then it gave birth to the 75 satellite consortium. There is a momentum. Dr. Mailsamy Anandre felicitated the team. So this is what we wanted with our MGR Education Research Institute when we launched our own satellite. We wanted to see you all at Sriharikota. So this is another important activity which could be carried out along with this small satellite program is CANSAT. See, CANSAT is nothing but a satellite built within the form factor of a 350 ml Pepsi Coke can. Within that volume, we could build a subsystem for entire satellite. So satellite is nothing but a combination of sensors and actuators. That's what yesterday TU Del Professor Venkata Prasad also highlighted. It is nothing but an onboard computer along with few sensors and actuators finally performing at 300 to 400 kilometers above Earth, low Earth orbit or at interplanetary missions. Even our regular smartphone, which we are carrying in our pocket, have onboard computer. It have its own telemetry, antenna system, and location system, GPS, etc. So same thing is there in regular satellite, whether big or small. This is a standard subsystem of any satellite. Few other slides just to highlight and give importance. Globally, how we can connect with this one single project. That was the biggest takeaway. Why we are saying that small satellite, big application? Because of the technological advancement, miniaturization of electronics, and very less volume. We could pack a good amount of electronics with lot of computational capability. There are university built with Raspberry Pi or Arduino board as an onboard computer. Then around that they built small subsystems and payloads which could be launched successfully and found in orbit successfully. So by seeing the good amount of students, I would like to just impress upon you science, engineering, technology is all nothing but a common sense. Science is a collective knowledge documented in a systematic manner. The very same science applied, it is called engineering. The application of engineering is called technology. Satellite is one such device which is the child of technological advancement. So what is not there, we are creating new. Every religion, irrespective of the origin, it considers its God as creator. So engineers are real God. They are creating something new which is not there or not existing elsewhere. So you are all engineers in the making, or in other words, you are all creators or gods in the making process. Satellites is one such project where we could establish the highest learning pedagogy within the campus. I'll dwell a few slides later. Anyway, I'm sharing this entire slide as a PPT document. It could be freely circulated, no copyright protected. Anybody can utilize this presentation for their own understanding or for dissemination. So for want of time, I'm quickly skipping few slides. So in Bloom's taxonomy, this pedagogy we are using in academic parlance. Creating something new is the highest level of learning process. So in satellite, we are creating something new, which is not there in our curriculum, which is not insisted upon by AICT or UGC or MHRD. So universities are investing time, energy, money on such a novel project simply because of the reason that it is highly interdisciplinary and multidisciplinary in nature. A good amount of real life exposure can be there, and it can lead to startups. Good amount of student project. Look at the slide. Last December, we could 2021 sign this MOU. Now, last 1 year, we could progress very well. I'm just showing few hardware which we have already realized. This is the structure. This is a one new structure, 10 centimeter by 10 centimeter structure, lightweight aluminum, 60-60. We can dismantle also. We can dismantle into this is the assembled CubeSat structure. And satellite will be look like this is the final satellite shape and size form factor. 3 kg volume, mass we are expecting. Different payloads, primary and secondary payload. Look at the various subsystem PCBs we could realize. This is the small satellite, and yet it have a very big application. Traditionally, a 10 kg or 100 kg satellite, what they could do in an orbit could be achieved with this 2 to 3 kg satellite. That is the evolution of technology. We have good amount of international network, and opportunities are available for students in various continents. For summer school, winter school, properly you can apply in time. You could get free of cost your training at outside India. It is very much possible. That is another biggest takeaway of this Dr. MGR ACS satellite. Good amount of ISRO approved facilities have been identified for developing and testing the subsystems and integrating the subsystems. And finally, we have to come out with an engineering model, which is in the process of making. After testing of the engineering model, we will go for a qualification model. Then the satellite will be subject to rigorous space qualification testing. It has to survive in the thermo-vacuum chamber because space is vacuum. And also the vibration test, shock test, when it was launched through rocket, either SSLV or PSLV or GSLV, it has to withstand the separation shock of first stage, second stage, and third stage. Finally, fourth stage, it will be launched into the respective orbit. And all these industries are ISRO approved facilities which are available for student project or internship. This is another takeaway for the students who are interested. I'm quickly skipping those slides. You can read leisurely. Yeah. Any academic institution, they are interested in quality publication with high impact factor journal, and every faculty have a high H index or item index. And also institutions want to outsmart other competitive institutions by the way of intellectual property rights. These are all possible with this one single project, a small satellite project. We could have a decent publication with a high impact factor journal. And also nowadays for NIRF ranking or NBA or NAC accreditation, everywhere these are all the metrics which are critically important that could be achieved through the project. And also I am always reminding all our colleagues working as a faculty member in every institution, including Dr. MGR Education Research Institute, and delegates from various academic institutions, have your Google Scholar ID updated with the current designation, and have your own Scopus ID, ORCID ID, Vidwan ID, and all the portals which are important because third-party evaluations are done automatically by various algorithms. So institutions' merit has to be demonstrated and quantified. There, our satellite project have a very big say. So this slide, just I would like to highlight the importance of questioning everything and anything. So without questioning, you cannot be progressive. The documented knowledge, which is the status quo knowledge, cannot help any individual to grow further. Any researcher or any person interested in innovative startup, they should questioning the existing status quo of the knowledge. That's what Einstein did. Einstein never accepted the understanding of the dynamics of Newton. That's why he gave birth to quantum mechanics. Same way, it was true to all great scientists. Look at the explorer view of our 1U CubeSat. We have onboard computer, we have electronic power supply system, we have solar panel. This is an explorer view just to give an insight into the commercial satellite. Within 1U, we could able to pack good amount of OBC and EPS. There is redundancy, multiple OBC, multiple EPS, all are possible. So the same manner, it's not limited to our creativity and innovation. Any student for their mini project or the final year project, they can take up each subsystem as one project. Look at the next slide, where I have delineated more than 30 areas which are realistically possible. Many other institutions we have experienced similar case study. 200 plus projects have been evolved within 2 years of time. Once they start building their own CubeSat, many students take up projects. OBC can be different variant of OBC, could be realized as a student project. Electronic power supply system. Within telemetry, we have variety of student project possible. Simple thing, antenna deployment mechanism. There are 100 ways are there to deploy antenna. Particularly for CubeSat, sky is the limit. You can have your own innovation and you can successfully come out with variety of ways you can deploy your antenna based on the form factor and constraint of the size of the satellite, whether 1U, 2U. Even the solar panel can be a fixed, rigid, attached panel to the surface of the CubeSat structure, or otherwise it could be a deployable panel based on the power requirement and life of the satellite and the active performance of the satellite, battery size. It's all important. So even power budget alone can be a mini project or the final year project. And students, when they think of a project, go in alignment with your domain expertise. Yeah, mechanical students don't need to try to do antenna design, rather power electronic power supply system. Electronic students can venture into electronic power supply system. Even when we have a training sessions, combined session with all students from various disciplines, sometimes they feel out of the place in the training. So I request mechanical engineering students to focus on orbital mechanics and finite element analysis and the thermo vacuum test related projects. Specialization. Some can look at debris management and core electronic students can look at system engineering. So space qualification test could be interdisciplinary, whether task test or random vibration test or sinusoidal vibration test or thermo test. So each subheading what we have given here could be logically extended as a project. Training can be given, courses can be offered. It could be credit course for honors degree or as a special elective, or even we are now working with MGR University to develop a curriculum for master's program in satellite engineering or satellite technology. So these are all very much possible. Even the same subsystems can be extended as a PhD research scholars problem. It could be published in good amount of quality journal Q1, Q2, Q3, or otherwise we can take it further as a patentable ideas, design registration. So many things possible with this initiative. That's what we have contemplated. And anyway, micro details can be worked out in the more face-to-face sessions. at MGR University and any other university or institutions interested in developing their own CubeSat or nano satellite, it is very much possible. Take the case of ground station, serial number 11, 12, 13. A good amount of research have been gone into this ground station. Now it become very cost effective and mobile ground stations are possible and we could able to realize. This is the roadmap we have given. Another big PR exercise which we have done with the government of Karnataka, which is also another proven case study. When we are having our own small satellite program live in our campus, we could have a very good outreach program. In Karnataka, we could able to reach more than 2.5 lakh students, participated in various competitions. All need not be a technical savvy or expert in design and development, but they have a fair knowledge of what is space environment, what is nano satellite, what is cube satellite, what is CAN satellite. They can participate in essay competitions and quiz competitions, painting competitions, physical static model display competitions. This could be a perennial activity in and around the institutional campus or across the state. We could launch online competitions and involve good amount of stakeholders. They are all our future students. So institutions ranking and also quality of the institutions and outcome-based education primarily depends on the intake quality of the students. How to attract the best talents in the country for our institutions. Look at the case of IITs or IIMs. Why these institutions are great? They are great because of they attract the bright students in the country. They have the best faculty in the country. Same is true with any deemed university or private university or engineering college. How to attract the best students and bright faculty to our campus. Have a vibrant culture of doing this kind of innovative novel project. So these kind of competitions help. We can conduct these competitions across the state or city based on our geographical area of interest or catchment area where we are attracting students regularly. Then those winners can be taken to Sriharikota for the launch of our satellite. This is another biggest takeaway which could be realized, which we have already experimented in Karnataka, where government of Karnataka initiated government school student satellite, which was later named after Punit, who was prematurely died. So this team, now we conducted competition across Karnataka, 2.5 lakh students have participated and 1,200 winners are identified. They all will be available in Sriharikota when we are launching this Punit satellite as part of 75 satellite. Maybe along with Dr. MGR ACA satellite will be one other satellite in that first batch of satellites to be launched to low Earth orbit. Even within that school, they have inaugurated the ground station by our Honorable Chief Minister of Karnataka with our Minister for Science and Technology. Even our team has participated in international competition, World CANSAT and Rocketry competition held at Serbia in last September. Incidentally, the Indian team from Bangalore, NTTF from Electronic City, won the international championship. And 6 teams from India got special jury award as well. So these are all the confidence building exercise. This is what we are expecting from our students and the delegates from this seminar. Whoever passionate about any subsystem of a satellite, try to put your hand, try to fabricate, participate in global competitions. Then sky is no more the limit. We can conquer the sky. That is what we wanted. Even good amount of teams participated in various international universities as visitors and summer school, winter school. Even we heard Dr. Ray Kawashima before my session. The first session she was there. She was the founder secretary general of University for Space Engineering Consortium. You all can become member. Even you can apply for this license. You can be a volunteer and you can serve the country as a freelancer. Because United Nations made it very clear that space for everyone and satellite for everyone, which is the mandate of UN. Based on that only, we also initiated the 75 satellite. This is the Moscow State University. They provide a lot of internships. So these are some of the snapshots. Just this Israel, Tel Aviv University and Samara University. See the left-hand picture where our students are standing. Samara, where the first satellite of the world, Sputnik, has been developed. The first cosmonaut have been sent to space, brought back alive. Anyway, we have next session with one of our Russian cosmonaut and scientist from Russian University. It's an exciting place. We can get a free training for 2 to 3 weeks in Samara. You can stay there and enjoy the campus life, and you can witness all the first-hand the technology available for space program. So 30 years before how the IT revolution started, now we are having this satellite revolution. This new space era is nothing but private industries are given opportunity to build and launch satellite. 10 years before, it is never dreamed of or never heard of. 99% satellite launched by national government or centrally funded space programs of respective country. Now space is open for everyone. Anybody can build and launch their satellite. That's why even in India we have InSpace. Thanks to Government of India, Prime Minister initiated as a bold step. Now private satellite can be registered and launched. This is the high time in the new space era or space 2.0. Private can participate, private startups can participate in this global initiative. This is the Sapienza University where deorbiting mechanism they focus in a big way. These are some of the snapshots just to give confidence that Indian students are no way inferior to anybody. 2019, we have won the championship at Serbia World Concert and Rocketry Championship. 22 also Indian team has won. This is the spirit which we want to disseminate across the country. We are helping more than 70 plus countries, and many institutions conducted CANSAT launch with even drone, if not rocket. With drone launch, we can do CANSAT deployment in the orbit. Next two slides, I will just conclude. Just a comparison. Look at the 1U CubeSat and CANSAT. Majority of the subsystems are common for both CubeSat and CANSAT. CANSAT is the beginner level satellite. Within 5,000 to 10,000 rupees, 3-4 students together can build and launch. Rather, you can participate in global competitions. This is the way we could perfect our knowledge and understanding about small satellite. This is just for academic interest, classification of satellite based on the form factor, shape and size. 2U satellite is nothing but 200 mm height, 10 mm by 100 mm by 100 mm cross sections. Same way 3U is 30 centimeter or 300 mm height, 10 centimeter by 10 centimeter cross section. So on and so forth. So these some of the CANSATs which we built and which has won the global appreciation. There is no limit. Based on your imagination, you can design either rectangle board or a circular board based on the budget. This is just for again academic interest. Understand what is nano satellite, micro satellite. These classifications are just for academic understanding. It's not the hard and fast rule. Nowadays, people talk about pico satellite, femto satellite. Within our hand, we can hold a satellite, 5 centimeter by 5 centimeter. Some are classifying it as a pocket satellite, pocket tube satellite. So all are possible based on our budget and constraint. You can build and launch. Yeah, look at the slide. So Samsung was known as a electronics company, used to build TV, washing machine, micro oven and all electronics white goods. Boeing was known as an aircraft company, but now everybody into satellite. So 3,000, 4,000 plus satellite they want to launch, they want to be in orbit. That's what the new space era or space 2.0 given birth to many companies diversified getting into space business. And also you all aware and understand how the GPS helped to have e-commerce to mobile commerce and mobile commerce to whatnot. So it need internet. So internet now coming through YFC cable, now it become wireless. It is going to come from space. Already we are experiencing the benefits of 5G. So that's why space become important, and every academic institutions want to get into this space sector. I thank Dr. MGR University. Right time they get into the building of their own satellite and prove to the world that they are no way inferior to any other great institutions in the rest of the world. This is Israel school student satellite. PSLV launched a few years before. We were helped them for getting the launch slot with ISRO. This is our Karnataka school student satellite. 4 such satellites will be built in 4 regions of Karnataka. This is some of our knowledge-based event. This is the event, current event, which we are all performing or undergoing. This national seminar is part of this initiative. Our testing facility, the satellite is undergoing qualification test, vibration test, shock test. This some of the hackathon and training program hands-on sessions held. The industry partners, Dr. Mir Ariel from Herzliya Science Center. He was the director of Nano Satellite Center, Tel Aviv University. He was instrumental for helping Israel school students to build and launch their own satellite. He is part of our advisory board. Even interested students can take up summer school or winter school training or any other short-term training at Israel. See, this collaboration, space collaboration is the biggest privilege in the contemporary new space era, where private players are taking bigger lead. And of course, every institutions are competing to create their impact in the students, to attract the best talent to their campus. NIRF ranking or NAC and NBA assessment or QS ranking, all are mandatory, are important for academic institution as an important metric for stakeholder to understand the level of intellectual capability of the institution. So in that context also, the small satellite program have a very big this is the last slide I would like to highlight. Don't be contented with the knowledge and understanding. This Katrathu Kaiman Alavu, Kallathathu Ulagalavu, it was said by YR, we all know from Tamil Nadu. But NASA understood the importance of this quotation or the proverb, what you call. They inscribed in the NASA entrance in the reception area to make their scientists to understand that be contented. What you know is a drop in the ocean, but what is unknown is the real ocean. So learning, lifelong learning is very much important, whether you are a teacher or student or professor or a postdoc research scholar. Learning is a lifelong process. Satellite project is one such a tool available for us to keep us engaged in the learning process and more sensibly to interact with the social applications. So with that, I conclude my presentation. Any questions we can take, one or two. Otherwise, this is my coordinates. You can reach me offline or online. I am sharing this PPT. Again, I thank ITCA for providing such wonderful opportunity, and MGR Education Research Institute, and Chancellor and our Rector, Dr. Vishwanathan. It is his brainchild. He initiated at Dr. MGR University, Dr. Cyril Raj and his team for such a wonderful interaction. Some of the case studies pictures are there at the end, which will give confidence. Many students built their own laboratory at their home itself because they are passionate about what they are doing. This is what important. We cannot learn certain things just for academic interest or getting good grades or score in our academics. But this should be a passionate project. Then it lead to a startup and whatnot. Even for higher studies, when you look for best campus across the world, when you pursue your passion, definitely you will be happy. At the same time, you can reach your destination. So I wish all the delegates of this national seminar and the organizer once again, thank you for the opportunity. Thank you, Ananda.
Thank you so much, Dr. K. Gopalakrishnan. It was a thoughtful and informative session, informative speech. And the takeaway from this session is actually that ITCA support and services, and as well as Dr. MGR satellite proposals and the international internship offers and all those things. Thank you so much, Dr. Any questions?